10 years ago, solar power was an expensive dream reserved for billionaires. Today, it's the cheapest source of electricity in history. For years, the world believed that making solar energy more affordable depended on scientists developing more efficient panels, better materials, and increasingly advanced technologies. But the truth that's now emerging is very different. Today's solar panels are already efficient enough and affordable enough, thanks in large part to AI-powered robots. Tesla is also planning to build what could become the world's largest solar manufacturing facility, with a production capacity far beyond what most people can imagine. What you're about to hear is truly fascinating. As we mentioned earlier, if you look back just 10 to 15 years, building a utility-scale solar farm was something only major corporations or governments could afford. Solar panels were extremely expensive, manufacturing capacity was limited, and every project required investments worth billions of dollars. But everything has changed at an astonishing pace. Driven by massive economies of scale and continuous technological improvements, the cost of solar panels has fallen to levels that were once considered almost unimaginable. As of 2025, the installation cost for a utility-scale solar power system in the United States ranges from 95 cents to $1.23 per watt. For a 1 megawatt utility-scale solar farm, the estimated cost is approximately $980,000, excluding land acquisition. That works out to a total installed cost of about 98 cents per watt. In many countries, solar power has already become the cheapest new source of electricity to build. Yet one question continues to puzzle many people. Why hasn't the overall cost of solar projects fallen even faster? The answer lies in a task that seems deceptively simple but accounts for a significant share of a project's total cost. A utility-scale solar farm can require hundreds of thousands or even millions of solar panels. Every single panel must be transported to its exact location, lifted onto the mounting structure, carefully aligned and securely fastened with bolts. This process has to be repeated millions of times. Not only does it require a massive workforce, but construction also takes months under harsh weather conditions. In the end, labor, transportation, and lengthy installation times, not the solar panels themselves, have become the biggest factors preventing the cost of solar power from falling even further. That's why the energy industry is beginning to witness a transformation unlike anything we've seen before. Instead of squeezing out another percentage point of solar panel efficiency, technology companies are now focusing on automating the entire construction process. A 9-ton AI-powered tracked robot developed by Terabase Energy has been built with one purpose: installing solar panels. Unlike the multi-purpose machines of the past, this robot is designed to perform a single task, and because of that, it can do it with a speed and level of precision far beyond what humans can achieve. The robot moves autonomously across construction sites using a tank-like track system. Equipped with advanced AI and an array of sensors, it can navigate rough terrain, identify the exact location of each mounting structure, lift solar panels weighing dozens of kilograms, and place them precisely where they need to be installed. It operates around the clock without breaks and is unaffected by extreme heat or harsh working conditions. Most importantly, the robot dramatically reduces the need for manual labor, which currently accounts for a significant portion of the total cost of building utility-scale solar power plants. By replacing thousands of hours of manual work with an automated system, developers can substantially lower the cost of each project while dramatically shortening construction timelines. According to estimates, this robot could reduce the installation cost of utility-scale solar farms by around 30%. That's one of the biggest reasons why the cost of solar power is now falling faster than ever. China has also begun deploying robots on a large scale across the solar industry for both installation and maintenance. Some cleaning robots are even equipped with integrated solar panels, allowing them to operate autonomously. One Chinese company, Lepting, used robots to build a 350-megawatt solar farm in Australia. According to the company, each robot can perform the work of 3 to 4 people, but much faster. Their long-term goal is to fully automate the construction of solar farms. This is more than just another step forward in automation. It could be the final piece of the puzzle that propels solar power into an entirely new era. As installation costs continue to fall, projects can be completed more quickly, built at larger scales, and deployed across more countries. That in turn means the cost of clean electricity will continue to decline, putting tremendous pressure on traditional energy sources. Interestingly, just as robotic technology is beginning to reshape the solar industry, Tesla is quietly preparing an even more ambitious plan. To most people, Tesla is still the world's largest electric vehicle company. But for Elon Musk, electric cars were never the ultimate goal. For years, he has repeatedly said that Tesla's real mission is to build a complete energy ecosystem, one in which electricity is generated by solar power, stored in batteries, and used to power not only vehicles but the cities of the future as well. While the public remains focused on robotaxi, Optimus, and AI, Tesla has been investing heavily in the energy sector. According to publicly available information, the company is developing a massive solar manufacturing facility in Brookshire near Houston, Texas. The project is envisioned as a vertically integrated production hub where multiple stages of the manufacturing process, from silicon processing and solar cell production to final panel assembly, will all take place within a single complex. What has especially caught analysts' attention is not just the scale of the facility but the long-term production targets Elon Musk has discussed. According to the available information, Tesla aims for an initial production capacity of around 100 gigawatts of solar panels per year, with the ultimate ambition of expanding to terawatt-scale manufacturing in the future. If achieved, it would represent a dramatic leap beyond the company's current production capabilities. But Elon Musk understands that simply manufacturing more solar panels isn't enough. If installation in the field still depends on millions of hours of manual labor, the pace of deployment will always be limited. That's precisely why the emergence of AI-powered construction robots is so significant. On one side is enormous solar manufacturing capacity. On the other is the ability to build solar farms faster and at a much lower cost through automation. When these two trends come together, the energy industry could enter an entirely new era of growth. If there's still any doubt that Tesla is truly serious about the energy business, the company's latest second-quarter earnings report speaks for itself. In just 3 months, Tesla deployed a total of 13.5 gigawatt-hours of energy storage systems, a 41% increase compared with the same period last year. It was also the second highest quarterly energy deployment in the company's history. These numbers make one thing clear. Tesla no longer sees energy as merely a business that supports its electric vehicles. Instead, it is becoming one of the company's primary long-term growth pillars. What's particularly noteworthy is that even though the energy division's gross margin fell from 39.5% to 20.4% due to tariffs and higher operating costs, Tesla has continued expanding its investments rather than scaling them back. This is a strategy Elon Musk has employed many times before, accepting lower short-term profits in exchange for gaining a long-term advantage through scale. That very strategy transformed Tesla from a small electric vehicle startup into the world's largest EV manufacturer. Now Musk appears to be applying the same playbook to the energy business. At the same time, Tesla's Shanghai Megafactory continues to ramp up production, achieving record Megapack deliveries across the Asia-Pacific region. Meanwhile, the Texas Megafactory has entered its commissioning phase with plans to begin manufacturing Megapack 3 and Megablock systems later this year. This means Tesla isn't just aiming to manufacture more solar panels. It also wants to build energy storage capacity on a scale the industry has never seen before. Elon Musk understands one fundamental truth: a solar panel only generates electricity when the sun is shining. A robust energy storage system is what transforms renewable energy into a reliable power source available 24 hours a day. That's why Tesla is developing all three critical pieces of the puzzle at the same time: power generation, energy storage, and automated deployment. AI-powered robots dramatically reduce the cost of building utility-scale solar farms. Megapack systems store the enormous amounts of electricity those solar farms produce, and solar manufacturing facilities capable of producing hundreds of gigawatts worth of panels each year will supply the equipment needed to scale the entire ecosystem. But Tesla's ambitions extend far beyond solar energy. The company is also building a dedicated AI chip manufacturing facility in Austin to accelerate the design and testing of next-generation processors. Over time, Tesla plans to establish an increasingly self-sufficient supply chain for AI logic chips, memory, and advanced packaging technologies. Another project, known as Terafab, has also been confirmed by Elon Musk, who said it will be unveiled at a dedicated event. The project is widely viewed as a key part of Tesla's strategy to manufacture AI chips for its full self-driving platform, the Optimus humanoid robot, and the powerful AI supercomputers that will train future generations of artificial intelligence. When you put all of these pieces together, the bigger picture finally comes into focus. AI-powered robots slash the cost of building utility-scale solar farms. Massive solar manufacturing facilities produce clean electricity on an unprecedented scale. Megapack and Powerwall systems store that energy. And AI chip factories provide the computing power needed for self-driving vehicles, Optimus robots, and the entire intelligent ecosystem Tesla is building. This is no longer just the story of an electric vehicle company. It's the story of Tesla's ambition to control nearly every link in the future value chain of the energy and artificial intelligence economy. But even if AI robots can dramatically reduce the cost of building solar farms, one question continues to be raised by critics of renewable energy. If millions of solar panels cover vast stretches of farmland, won't valuable agricultural land be lost? Interestingly, a large-scale project in New South Wales, Australia, is proving the exact opposite. Rather than replacing agriculture, solar power is actually helping farms become more productive than ever before. At New England Solar Farm, one of Australia's largest solar projects, more than 6,000 merino and crossbred sheep graze beneath approximately 1 million solar panels. Once the project is fully completed, the site will feature around 1.5 million panels with a total generating capacity of 720 megawatts, enough to supply electricity to roughly 300,000 homes. What's truly remarkable is that livestock farming hasn't just continued alongside the solar installation, it has actually become more productive. According to the farmers involved in the project, the solar panels have created a highly beneficial microclimate. The shade cast by the panel arrays helps the soil retain moisture longer after dewy nights, allowing grass to stay greener and grow more vigorously despite Australia's hot, dry climate. During the summer, the sheep have shelter from the intense sun, significantly reducing heat stress. In winter, the panels act as a protective barrier, shielding the animals from frost. As a result, the sheep are healthier, wool quality has improved, and some farmers even report that they can raise more sheep on the same amount of land than they could before the solar farm was built. The benefits don't stop with the farmers. Energy companies also save on maintenance costs because the sheep continuously graze beneath the solar panels, naturally controlling vegetation, reducing wildfire risk, and minimizing the need for mowing or chemical herbicides. Rather than competing with agriculture, solar power is creating a mutually beneficial partnership in which both industries thrive. For farming families, the financial benefits are equally significant. In addition to income from livestock, they receive long-term lease payments for allowing their land to be used for solar development, often under agreements that last for decades. This provides a stable and predictable source of revenue, helping shield them from fluctuating agricultural commodity prices and prolonged droughts. Many families say this dependable income has enabled them to keep their farms in operation and pass them on to the next generation. This may well be the final piece of the puzzle Elon Musk has been working toward all along. If AI-powered robots can dramatically reduce the cost of building solar farms, and projects like New England Solar Farm prove that agricultural land can continue generating value, then one of the biggest obstacles to expanding solar energy has all but disappeared. Tesla is investing in solar panel manufacturing, Megapack energy storage systems, artificial intelligence, and automation to build a fully integrated energy ecosystem. As manufacturing costs continue to decline, installation becomes cheaper through AI-powered robotics, and farmland serves both agriculture and electricity generation at the same time. Solar power will no longer be just a clean source of energy. It will become a more compelling economic solution than ever before. Perhaps that's why the debate of the future will no longer be solar power or agriculture. The answer is becoming increasingly clear. Solar power and agriculture can thrive side by side. The fields don't disappear beneath the solar panels. Sheep continue to graze and flourish. Farmers gain a reliable new source of income, and the world gains more clean electricity at an ever lower cost. This is the truly sustainable model that many countries are now pursuing, and one of the key reasons the global solar energy revolution is accelerating faster than ever before. That's all for today's deep dive into solar power. If you want to keep exploring how Tesla builds the future, hit like, subscribe, and join us for the next engineering breakdown. Goodbye.